section 4.3. This section, we want to show application of two equation and two variable in word problems, or some people call it story problems. How we do the translations, and we use some of this equation in real world. So you start with this example. There are two aircraft carriers A and B, and carrier A is longer than length than B, and the total length is given, and the difference is also given. So these problems, when you want to work on word problems, what you do first, you get to look at the last statement to see what is unknown. Length of each carrier. Each carrier, we need to know the length, right? So there are two of them, A and B. So here, you assume that the first one, length, these are the length. Is A, the second one is B, okay? And they're saying A is longer than B. So obviously, whatever length of A is greater than B. The first equation is here. A is longer. The total length is 2198. So we assume length of each is A and B, right? So the sum is 2198. The difference, I mean, when you subtract these two, is 14. So now you come up with two equations and two variables. It's very simple to do because B and minus B, they both are equal and opposite. So you cancel that and you come up with value of A. When you find your A, then the first one is A plus B is 2198. So all I need to do is just substitute there to find my B value. Okay. So that's how to do the translation of these word problems and using two equations and two variables to solve it. Again, the beginning, length of each is unknown, A and B. The second problem is a plane travel, and this plane travel with and against the wind, okay? So when you, let's think of another example. Let's think that there is a river here. And obviously direction of the water or current is in these directions. When a person, let's say there is a swimmer and he goes with 8 miles per hour, he can swim 8 miles per hour. And the current, rate of the current or the water is 2 miles per hour. So when he swims with the current, obviously goes faster, right? So his rate is 8 plus 2, or 10. When he swims with the current. Now let's say he swims back. When he swims back from point B to point A, the current is against him. So it would be 8 minus 2. So the same idea also works for the plane. When the plane is going with the wind, let's say if the plane is X and the wind is Y, when you go with the wind, it goes faster, X plus Y, and when you go against the wind, then it's x minus y, right? So when you go with the wind, is x plus y, means a speed of the plane plus speed of the wind, or rate of the plane plus rate of the wind. And when you go against the wind, when the plane travel against the wind, would be x minus y. So we are using this idea for these problems here. So what they're asking here is at the end, see, if I read the last statement for the word problems, read the last statement of the problem to see what is in question. A speed of the plane and a speed of the wind. They're asking for these two. So one is x, one is y. So here, rate of the plane is x, and rate of the wind is y. So what we do is we understand that there is a formula that you need to know, and that is distance is always equal to speed multiplied by time. If you drive a car every day, you are dealing with this formula, okay? So let's say here, I drive with rate of 55 miles per hour. I drive with rate of 55 miles per hour, right? Rate, mile is the distance, and hour is the time. Or rate is equal to distance divided by time. And if I cross multiply, then distance is equal to rate multiplied by time. Okay? So again, as I said, when you drive a car, you're dealing with this formula every day. So rate is the distance divided by hour. Okay, so based on that, we create our table here. Look. Rate multiplied by times is the distance, okay? When the plane travels with the wind, is x plus y. The rate always add together. Time is given in the problem. So when you go with the wind, it's 2.5 hours. Distance also is given. When travel against the wind, same time. Time doesn't change. Okay, it's 2.5 and is x minus y. And is given the distance. So now I have two equations. See, rate multiplied by time is distance, means this 2.5 times this is equal to that. So that gives us these two equations. And if you divide both sides by 2.5, it's easier to do the problems. So in that case, you come up with these two equations here. See, I divide both sides by 2.5, 2.5, and then I have x plus y is 570 and x minus y is 450. Then I solve these two equations, y and minus y cancel. See, that gives you the value of x, which is rate of the plane, 510 miles per hour. And then you could, and x plus y is 570, one is already 510. That gives you the value of y. See, 60 miles per hour. So this is rate of the wind, and this is the plane, miles per hour. Unit is not that important enough. In math, we don't really care that much about it. So, but here you understand that since we're talking about the rate or speed, it has to be miles per hour, mph. So first we need to come up with two equations based on that formula. Okay. And then solve a system of two equations and two variables. We have this one also that is number 3 in the homework. A woman bought some large frame for $19 each and some small frame for $7 each at a closeout sale. If she bought 26 frame for $278, how many of each? See, last statement is how many of each type. So number of large frame and number of a small frame is unknown. For instance, here, frame is $19 each. So if I tell you I have 5 large frame, what would you do to see how much you have to pay? You take that 5 and multiply by 19, right? If I say I have 7 large frame, how much would that be? You take 7 multiplied by 19. What if I say I have X number of large frame? You take X multiplied by 19. Or if I give you, I have Y number of small frame, how much is that? You multiply by 7, correct? So in that case, here, number of large frames is X, number of small frames is Y. In the problems, we say there are 26 frames. So X plus Y is 26. And we spent $278, right? So we have X, number of large frame is X, and each is $19 per frame. So you take X and multiply by 19. Number of small frames is Y. We don't know how many, but regardless how many, you take that always and multiply by price of one frame, which is $7. That also given in the problem. So you have 2 equations and 2 variables. And remember, if you want to eliminate X, I have to multiply the top one by minus 19. When you multiply by minus 19, then you could eliminate X. You find the X and then you substitute that for Y to find the Y value. Okay. Then on these problems, number 4, we need to do the translation here. Again, here in these problems, what is unknown in this problem? We are talking about 2 numbers. First number and second number. So you're going to make an assumption. Your first number, let's say, is X, and second number is Y, because these 2 are unknown. X and Y. And then we have to translate one by one. He said one number is 8 less than the second number, right? Okay, so here. First, assume the first number is X and the second is Y. One number is 8 less than the second number. See how I translate it. One number or the first number, same thing. Is we assume is X. Is means equal. 8 less than second. Second is what, right? 8 less than Y is Y minus it. Be very careful about this. So it's like you have $20 and I have $2 less. So how much do I have? 18. See, you have $20 and I have, let's say I have $3 less than you. So it would be 20 minus 3, okay? 8 less than second. So it would be Y minus 8. So this is one equation, okay? Save that equation. The second translation is this. They are saying 3 times the first, 3 times the X is equal 6 more than means positive, 5 times second. 5 multiplied by the second. See the translation of that one here? So now you have 2 equations and 2 variables. So you do the translation first, right? So the best method to use here is elimination because you already have the Y. All you do is take this Y, X equal to this. You take this and substitute for X. Remember, not for 3, for X. So whatever comes here, you have to multiply 3 by that. Yeah. And then when I distribute 3, I solve that equation to find my Y value. When you find the Y value, then you could plug that into first equation to find your X. We have another problem here in your homework. At the concession stand, 5 hot dogs and 4 hamburger cost this much, and 4 hot dog and 5 hamburger cost $15.25. What is the question here? What is the cost of hot dog and what's cost of the hamburger? So these are your X and Y, because it's unknown, right? Okay, so here, look. Cost of 1 hot dog is X. We don't know how much is X dollars, and that is Y dollars, right? We don't know what it is. But you buy 5 hot dogs and 4 hamburger, and that costs $14, okay? That's one equation. Second equation, we buy 4 hot dogs and 5 hamburger, and that costs $15.25. So these are your equations. And now I want to eliminate X. Remember the interchange, so we do the interchange here. We put 4, -4 here and 5, and you multiply that. That gives you the value of Y. And then you find your X. $2.25 and $1. Hot dog was X and hamburger was Y. So cost of 1 hot dog is $1 and cost of hamburger is $2.25. Now we go to the last one here. This is interesting problems. Number 7. I skip number 6 because it's very similar to the rate change. This one is 2 different agencies, Primo Car Rental Agency and Ultimo Car Rental Agency. What is unknown is mileage, number of mileage, how many miles we travel. So what they're saying is this, they're saying Primo charge $35 per day plus 0.25 per mile. The other one, $40 per day more, and 60 is more per mile, right? Okay, so in that case here, this is how you do the translation of these two. So the first one has $35 flat per day and 0.25 times how many miles? So if I go 10 miles, we multiply by 25 cents. And this one, and the second one, 60 cents, right? They're saying that Ultimo charge is twice the Primo charge. So it means you write this equation here. And then when you do the distributions, find the miles. Okay, so that would be end of section 4.3, which, as I said, is application of 2 equations and 2 variables.